Hi, I'm the Undead Dev. Welcome to my channel. Today I'm going to walk you through a little PCG project I built that lets you draw power lines in your level with a single spline. It's fast, it looks realistic, and it even uses Unreal Engine's cable component, which is a fun little challenge, but more on that later. Let's dive in. Before we get started, let's make sure you have a few things in place. First, enable the PCG plugin in your project settings. It's off by default, so just check that little box and restart the editor. Second, for the phone pole mesh, I'm using the one from the Western Desert Town collection on Fab. I'll have the link in the description, but this method should work with any phone pole meshes you may have or make. Finally, a quick heads up, this tutorial assumes you're comfortable with Unreal Engine and the basics of the PCG system. Let's pause for a minute and look at what we'll be putting together. The power line is split into two core parts. The poles, as I said, I'm using the Western Desert Town pole mesh, but this method should work with any mesh you can get a hold of. And the cables. For that, I'm using Unreal's built-in cable component. I could just use a spline mesh, but I think there's a lot of tutorials out there that show you how to use spline meshes in PCG. And I wanted to do something a little different, which means there will be some world to local space conversion, merging neighbor point data into one set, and overriding actor parameters from inside PCG. All right, let's jump straight to the graph. I'm going to disconnect the graph and reconnect it step by step so you can see how this all works out. First, let's make this graph a tool you can use from PCG mode. Click on a blank spot on the graph. This will bring up the graph's properties. In the tool data panel, set display name as powerline tool, the description as draw power lines, the new actor label as powerline, and is preset to true. Then make sure the compatible tool tags field contains spline tool. That's what tells PCG mode which tool to enable this for. Now we can go back to our scene select tool and draw out a spline. We'll use this spline to test our graph. Now let's set up our spline sampling. I'm creating a simple parameter called pole distance and feeding that into the spline sampler as the distance increment. Hit debug in this node to see where the points are being placed. You'll notice that they're not always touching the terrain. Sometimes they float a little above the terrain on the spline itself. You'll also notice that they follow the spline's full rotation, so they don't always point directly upwards. To fix the first problem, I'll project those points onto the landscape. After that, clamp the rotation to point straight up. I'm clamping it so we can tweak it later if we want a slight lean along the spline direction, but for now, let's set it to 0. Debug again, and you'll see the points are pressed against the terrain and all pointing upward. Now, because I know the rotation of my mesh, I'll rotate the points in the correct world orientation with a transform points node. You may not need to do this. Then spawn the pole meshes at those positions with a spawn meshes node. I'll use my pole mesh as the only mesh description, and done. That's it for the poles. Now we need to create the cables. Start with the original spline points. I create two attributes, cable horizontal offset and cable vertical offset. Using the make vector node plus a transform points node, I offset each point so it lines up with the pole model. Adjust those numbers until the points sit where you want the cables to connect. Trial and error works fine here. Now we need to get the next cable's position. The cable component needs a start and end position, so each point must know where the next point is. This was a little difficult to figure out, but here's how I managed it. We can duplicate the point arrays, shuffle one of the point arrays so that its index is off by 1, and then set attributes from that array back to the original array. Let me show you what I mean. First, let's remove the first point using an attribute filter set to look at indexes greater than 0. Because we can see that the first index is 0, this should filter out just that record. Next, we use a merge node to add that point back to the end of the array. You'll have to add a second input bin because order matters here. So in input 1, include everything that is not filtered out, and in input 2, put that original filtered out point. If we press A and inspect the nodes, you should now see that the original point at the end of the list instead of the beginning. Use set attributes node to set the position of the shuffled points as next position on the original points array. So now every point should have its own position as position and its next neighbor's position as next position. Remove the last point. Because we filled the gaps between the poles with cables, there will always be one fewer cables than there are poles. If you have 2 poles, expect 1 cable to connect them, 3 poles, 2 cables, and so on. Because we're creating 1 fewer cable than poles, we must strip out the last point. If we didn't, we would generate an extra cable on that last pole that reached all the way back to our first pole, and I'd like to avoid that. To do this, use a getElementCount node, subtract 1, and then filter that many elements off the array so the cable never loops back to the first pole. Repeat this for the other side. Copy and paste that whole block, but multiply the horizontal offset by -1, so the cable goes to the other side of the pole. And that should give us both points on each pole. Finally, merge all the connecting points together into one array. Now we spawn a new actor using the spawnActor node. Set the actor template to cable actor. The point position will become the cable start, and the next position will become the end location. To override the cable component's end location on spawn, add an entry to spawnActor property override descriptions. The input source will be next position, and the property target will be cable component dot end location. Notice we're specifying the component name because the parameter lives inside the cable component, not the cable actor. When you run this, the endpoints will update, but you'll notice if you look that they're all wrong. Well, it's because the cable component in Unreal Engine expects local space coordinates, and we just set them in world space. There's probably a way to convert the world space coordinates into local space coordinates without leaving PCG, and if you've figured that out, feel free to leave a comment. But I found a quick fix by creating a small blueprint that handles the conversion. Here's the blueprint I created. It's called BP World Position Cable. You'll notice it just has a cable component as the root. In the variable panel, I added a world cable end, and this is what will feed from PCG. In the construction script, you'll see an inverse transform location node that takes the world endpoint, converts it to local space relative to this actor, and then feeds that into the cable component's end location. You'll see I also set the cable's length by subtracting world cable end from the actor's location, taking the vector length, and multiplying it by a float. In my case, I chose 0.8. This changes how much the cables sag in the middle. Higher values will cause higher amounts of sag. I found 0.8 works well for my needs. Now, we'll go back to the PCG graph and update the spawn actor node to reference BP World Position Cable instead of the generic cable actor. Keep the same input source, next position, but change the property target to world cable end. And that's it for the graph. Now head back to your level, switch to PCG mode, draw a spline, and you'll see Powerline tool in the Draw Spline menu. Click on it, then click and drag and lay down power lines that automatically connect the poles. So that's it. If you thought this was useful, feel free to like or subscribe. It would mean the world to me. Thanks for watching.